to introduce Alexandra Pulwicki, who's doing her MA in Earth Science, and her topic is on tracking snow on glaciers.
100 meters from the edge of a small glacier, a single snowflake falls and lands gently. It is mid-October, the beginning of the winter season, and as the skies fill with thick stratus clouds, more and more snowflakes begin to fall, each one a unique geometric configuration. The first storm of the season passes quickly, and soon a stiff wind begins to blow. The wind scoops up our snowflake and many of its neighbors and moves them down glacier, where they settle in a slight depression, bond together, and form a hard wind crust. As the season progresses, more and more snowstorms pass over the glacier, each one depositing and repositioning millions of snowflakes. Eventually, a thick blanket of snow covers the entire area. A temperature gradient now exists between the cold surface air and the relatively warm snow base, and this forces water molecules to move, rounding out the snow grains. Many months of this snow metamorphosis completely transforms our original snowflake from its shape. As the days grow longer and the amount of radiation coming from the sun increases, the air temperature rises. The warm air permeates the snowpack, forcing the snow grains to join together, growing larger and larger. Meltwater trickles down, releasing energy and further warming the snowpack, allowing the grains to join together, continuously growing larger until they form a dense mass of old snow called fern. As the years pass and the winter-summer cycle drives on, more and more snow accumulates, gradually compressing the fern and squeezing out and sealing off air pockets until the fern becomes ice. Our snowflake has now become a part of the glacier it first landed on. Snow is the genesis of glacier ice, which in turn regulates ocean currents and global climate patterns, and is a valuable source of irrigation and drinking water. The goal of my project is to tease apart the factors that affect how much snow accumulates on glaciers, and to then understand how that affects the health of these climate change sentinels. We use snow probes to collect thousands of snow depth measurements on 3 glaciers, and I now use statistics to relate the amount of snow and the topography that it lands on. The data show that the variability and spatial patterns of snow accumulation on glaciers differ, even on nearby glaciers. Further, how you collect the data and how you choose to interpolate that data can create differences in our estimation of a snow accumulation. So, despite our best efforts to make grand conclusions and gross generalizations, we find that the way snow accumulates on glaciers is as unique as the snowflakes that first fell on them. Thank you.